back. Apologies for my absence for a couple of days. Was engaged with certain issues that I had to be away. I missed you all very much, and I hope you people also missed me. So there were certain things that were beyond my control, so I couldn't attend. I'm sure some of you are aware. Anyway, I'm back, and not that I'm Atlas who's holding the earth on me. It is the heavy lifting is done by our veterans here, Sharath and Barney. They are the ones who are doing the lifting. I'm only poking them, uh, you know, trying to use them as a punching ball to understand what are the various things so that the answers that they provide is useful for our participants who are attending these sessions online. So today we are going to be discussing about the supervised techniques. We've already had some preliminary discussion about supervised technique, what is what, and that was more of at a high level or at a very, very basic level of supervised techniques. Now, this could be treated as a slightly more detailed or a more deeper interview where we are going to understand the reasons or understand why a particular supervised learning, etc. All right. So a straightforward question, a simple question would be explain about regression, explain about decision tree. All right. A slightly different perspective or a different tangent to that question will be why did you choose this particular model? What are the reasons behind it? So on that note, I like to start today's session with Barney. Barney, I'd like you to take the reins today. So can you please explain your logic or the rationale or what are the key points that you keep in mind before you decide the model selection, which can be helpful to our participants? Yeah.
Absolutely. Sure, Nitin. Thank you so much for asking that question. It's an extremely important interview question. Having said that, I would like to draw the attention of the participants towards this beautiful infographic which we have created. And within, I think, 4 hours of posting this, we have garnered approximately 4,000 plus views. That means this is worth, having a look at. While we have this CRISP-MLQ framework, which has a lot of phases, one of the key phase is model building. And when it comes to model building, what are the things that one has to focus upon, right? So if you ask me, before selecting a model, you need to understand from business standpoint on whether accuracy is more important or explainability is more important. Based on that, we decide on which algorithm we need to proceed further with. As an example, if you're working with a bank or if you're doing a project for a bank, then they will certainly expect the model to have better explainability as opposed to having higher accuracy, right? So let me play this. This video would make more sense. Just a moment while I try to pause this. Okay. So here we go. So when it comes to model selection, you need to look at explainability, right? And according to European Union GDPR norms, and a lot of countries have their own data protection norms, data security, privacy norms, artificial intelligence, legal documents are being prepared in different countries. So if you reject a loan, for example, why did you reject the loan is a question which the customers whose loans are rejected might ask you, and you'll have to give a valid reason on why you have rejected. Not just that, you also need to think about accuracy. If customer says that, you know what, I don't really bother about explainability, but for me, accuracy is more important. If the customer says so, we have to resort to some kind of black box techniques like neural network algorithm, which gives you amazing accuracy, or ensemble model, which gives you better accuracy. And also, where are you going to deploy a model? Are you going to deploy a model on some kind of an IoT device or on your mobile application on which the model should be of lightweight? If you were to deploy on these kind of endpoints, your model should be lightweight. So what kind of model compression techniques would you apply? What kind of algorithms would ensure that the final model to be deployed is of lightweight? And also you think through on what amount of data you have. And if you're choosing neural network kind of algorithms, it would take a lot of time to train the models. Is it conducive to take that route? Or would you want to use pre-trained models? Pre-trained models are models which are already trained and you're going to reuse those. And not just that, you also look at performance. If you're building a model in the space of, say, stock market prediction or credit card fraud, you need to do real-time prediction. Even in the space of aviation, you need to do real-time predictions. In those kind of scenarios, performance also matters. The speed at which your prediction results will be spilled out by your model would be important. Then while you select the model, you also need to think about what are the various resources that would be needed. Okay, and certain algorithms will need huge compute. Again, a classic example is deep learning. Deep learning algorithms require a lot of compute. They run when you have GPUs, etc., given the complexity of the data, etc. How complex your model can get is also something that you need to define, because sometimes what happens is you might end up building a very complicated model given the business problem, and you might achieve your objectives. But when your model is maintained, it's not a one-time journey that you build the model and job done. Eventually, you need to maintain the model, as in how you get new data, you need to retrain your model. You know, all those aspects are considered. So given all those things and given the kind of human resources data scientists that you have for maintaining the model, you need to think about how complicated your model can get to solve your business problem. If you go overboard and try to make it extremely complicated, then your junior data scientist might not be able to maintain that over a period of time. And explainability, we have already discussed about that. Scalability. If you build a chatbot kind of an application, maybe today there are only 1,000 users who are using the chatbot and the performance is good. What if it becomes a success? Every project is started with the intention of making it a success. And what if it becomes extremely successful and 100,000 people starts accessing your chatbot concurrently? Will your model support, or would your model crash, saying that too much of load, so I'm crashing? And robustness. If I'm going to build a model on, say, data where you have various inputs, age, say the minimum age was 18 years and maximum was 40 years. Minimum age was, minimum income was $5,000 and maximum was, say, $12,000 in your training data. If at all there is slight reduction in the future data, say you had a new customer whose age was 16 years, or say you had another customer whose age was 45 years, would your model still work, or will it throw error? To what extent would your model start giving reasonable accuracy, given that your future data is not lying within this range, okay, on which your model was actually trained. What if the salary was less than 5,000 or greater than 12,000? To what extent is your model accommodating the values which fall outside the range of the data on which you have trained your model? So that's robustness. So all these are the aspects that one needs to consider before selecting the model. And one more extremely important thing is reproducibility. I would probably leave it to Sharath to throw some more light on this aspect of reproducibility. Yeah. Thank you, Nitin. Over to you.
Thank you, Bernie, for that detailed explanation. As always, quite enthralling and quite engaging. Of course, the visualization also is quite amazing. No wonder we are garnering so many views for that. Yeah. So, Sharath, could you please continue from where Bernie left off, specifically with reference to the reproducibility, but also anything more that you would like to add with reference to the choice? What are the under what framework do you decide the choice of the model?
Yes, Nitin, thank you so much for asking that question. And good evening, everyone. I would basically talk about the reproducibility and the very another important aspect of ensuring that the quality of your model is always under the acceptable. I mean, it has to be acceptable, right? So when you are trying to understand the business scenarios, when you're trying to gather the requirements and try to decode the business problem, you probably come up with certain plan, right? Planning phase. And this is where you're going to define your scope. You're going to try and define your objectives or objective, and you'll identify what constraints you will have in your solution development. All this is basically interpreted, researched, and based on all this understanding, you're also going to try and do benchmarking, right? So success criteria is another point that we need to. When we develop any model, for that matter, if I have to consider that we are going with some machine learning model, the machine learning algorithm that we are developing is done on a sample data, historical data, right? This would be your sample data on which you are training your algorithm. And this algorithm should give us the results which are acceptable. And that acceptability comes when the algorithm is meeting the success criteria that we have upfront defined in our planning phase. If it doesn't come up to that acceptable level, we do tuning, right? So this is something that we are very much familiar with. But the important point here is when you try to implement this at production level, when you're trying to productionize the best model that you have got, you need to ensure that there is consistency in the performance of this algorithm. And for that, of course, we were going to evaluate the model on the training data, test data, or even before test data, we will be doing validation of the algorithm on validation data. And then we will also use test data. And if the algorithm is consistent with all these different parts of your data, historical data, and also it has to meet the success criteria, of course, that is another important prerequisite before we decide that this is the best model. Once these checks are done, once these algorithm passes through these checks, then it has to be productionized. But the monitoring and maintenance part comes here, right? This is basically from a reproduction or reproducibility aspect, because the algorithm is designed or trained based on the pattern, based on the information that the data carried in the past. But business will drift, business will improve. Based on that, the data will also improve. So we need to also ensure that we keep a close watch, right? And this close watch is to monitor all the metrics that we are capturing when the model is getting evaluated, trained and evaluated. Those metrics will always be used for comparing the model's performance in the production mode. Now, this is very essential. These metrics are saved, and we are using these metrics to compare once the system is implemented in production. Now, what happens is once the model is deployed, it becomes a service. For the end users, it is a service and it gives you some functionality. So as an end user, we will try to use this service. And to do that, we pass some input. And this functionality or this ML algorithm or service is giving us the output. Right? And we try to safeguard both of these input and output that is predicted back into the database. This information, which is collected now after the deployment, will be used for comparing the performance of the model in production for consistency purposes, reproducibility purposes. So it has to behave as if it has behaved on the historical data. Now that happens only when your data has similar properties. So we are also going to maintain the metrics that we captured as part of our EDA on our historical data. And we are going to check what is this input data that the system is or the service is getting. And based on that, all these comparisons, we will be able to measure the model's performance with respect to reproducing the same results. And in practical cases, we also try and add some noise to the data frames. Because real world, we never know what kind of challenges we might encounter. So what we do is, while we do the testing on the test data set, in a lot of instances, we wanted to, if the business case is very dynamic, we always want to check whether the model is generalizing the problem statement, generalizing the issue, right? Finding a generic solution. That's what generalization basically means. Now, what we do is we take this test data and we add noise to it. Noise could be exceptional inputs or missing data, right? Or some kind of a weird input that we give, which probably is like a completely different value from your expected historical data behavior. So these kind of noise values are added into the data manually. And then we try to see if the behavior of the algorithm is as expected. These are all the checks that we do in order to ensure that there is continuity or there is quality, I should say, in the model's performance. So this is something that we experiment on. But Nitin.
Yeah, thank you, Sharad. So yeah, I have a couple of questions, but I'll address it to Barney this time, because Barney had given me the answer about the choice of the model. So Barney, once we have decided the choice of the model, it could be maybe you could probably get one single model or maybe 2-3 different models, and within those 1 or 2 models, you may have done multiple variants of those models by doing hyperparameter tuning, etc., to get the best fit. Now, my question is for a client in the perspective of we as the vendor and the client, what is the requirement do we do as part of our, the processes? Do we have to give some kind of a report that these are the 3 models, each of these models I had 15 varieties that I have done, each of the combinations, this is the, so any such report is required in your experience? Does it really help, or ultimately the customer says, I don't care about all those things, make it ready, give me the final one and put it in production, and I'm happy. So what is the general understanding or expectation of the client in this scenario?
Sure, Nitin. It really boils down to what kind of team the client has. If the client has a team of data science professionals or a chief data scientist, then another question might arise on why do they want to outsource? For various reasons, for security reasons. If they're building employee attrition model, for example, obviously they don't want their own team of data scientists to predict and say that, hey, this employee might resign in the next 6 months, this employee might resign in the next 20 days, whatever. Because what happens is people don't have the required maturity to keep these things as secret. And they might go and disclose saying that, you know what, a model has predicted that you'll resign in the next 2 months. So that employee, if wasn't even thinking about resigning, might start looking out for a job or might feel demoralized that my own company is kind of doing predictions, these kind of predictions only. So when those kind of clients outsource you, then they might expect you to showcase all the different algorithms that you have experimented with and the various hyperparameters that you have experimented and which setting has given you the best result, which algorithm, which set of hyperparameters has given you the best result. Maybe they would be interested to know that. And also they would be interested to know the performance. What is the kind of hardware on which you have run this algorithm or trained your algorithm? And what is the kind of hardware on which you have tested your algorithm? Okay, so probably they would be interested to know even that. But in most cases, barring these kind of exceptions that I've just explained, customer would not be really interested in how many lines of code you have run, what algorithms you have used, what are the hyperparameters that you have used. In most cases, they might not be even aware of such things. They will only be interested to understand that, hey, this is a business problem. By implementing your project, AI project, I am expecting this much as revenue, return on investment. Did I achieve that or not? In most cases, customer would be interested in that end result. So as opposed to spending too much of time in that documentation part, focus should be on whether the success criteria from business standpoint and economic standpoint are achieved or not. Anyways, machine learning success criteria, people will anyways evaluate as a data scientist. However, having said that, there are other reasons why documentation is extremely important. Because if you claim that you have achieved an accuracy of 98%, then in most cases, customers would expect you to replicate it, showcase that it's truly 98%. In this kind of a scenario, you need to document what is the machine learning algorithm which has given you 98% accuracy, and what were the hyperparameters that were tested, which has actually given you 98% accuracy. Not just that, you also need to document what was the operating system, what was the software version, Python version, or your SQL version, whatever, database version, etc. What was the compute that you were using? What was the memory? What was the processor? Were you using GPUs? All those should be documented along with all the libraries which you have used in Python, along with the versions of those. Only then will you be in a position to replicate and support your claim that this is accuracy that you have achieved. And in most of the cloud-based auto ML algorithms, where one need not even worry about what are the different machine learning algorithms which exist. You just apply your inputs and output to your algorithm to auto ML, and that would automatically experiment with plethora of models with bunch of hyperparameters with various permutations, combinations, and then give you one best model out. While it does that, AutoML would also document all the experiments performed and what is the best model, what is the hardware, what are the softwares that you have used, what are the libraries that you have used. Everything would be documented. So you can even forget about this aspect of documenting each and every part if you resort to cloud-based AutoML techniques. Yep. Thank you.
Thank you.
Nitin,
Thank you,
and over
Bernie.
to you.
Yeah. So basically, the rationale or the logical reasoning behind that particular question is traditionally when we talk about software deployment and you have a customer and a software service provider, documentation is a major chunk. The things are in ready, just put in production, it is working, but where is the documentation? I will not release the payment till the entire documentation, every line of code is explained with the commentary, etc. It is available to the client or not. So I wanted to understand the data scientist's role in that particular context. So thank you for clarifying that there, Bernie. Yeah. So Sharath, we have just a couple of minutes left. So could you, we'll try to, connect the entire two edges. So we have the model development or the model creation with reference to supervised. So once it is created, Bernie just briefly spoke about cloud deployment, etc. So could you just touch base upon the types of deployments that are pretty popular and how you decide to choose a particular deployment methodology or a deployment tool? Can you just throw some light there?
Yes, Nitin. Thank you to bring up that question. That is another very essential aspect of productionizing an ML model, ML service. Because ultimately you need to assess on what is that solution being used for, in what conditions, how many people will be using that solution, whether it is being concurrently used, whether it be used sequentially, etc., will be something that we have to assess. Now, this job of assessing the requirements is not sole job of data scientist. It actually combines the capacity of data scientists. It combines the capacity of your IT team, because they ultimately have to decide your hardware, right? And that's going to be a very essential aspect on where your solution is actually going and sitting so that it supports the future requirements. And these basically tasks that we are talking about, right, basically can be defined as MLOps. So if you see this is the very, very popular diagram, which was given by Google. And it speaks about how essential is to assess the requirements with respect to the hardware and other software components that we are going to use along with your machine learning code. That is the reason why I was saying this is a very, very essential question. So when you talk about deployment, if I have to put it at a very simple, in simple way, the deployment basically consists of three aspects. I should say three aspects. One is your hardware. The other one is your software. The other thing that we are going to talk about is the data that you are using. Okay, so three components. Software is nothing but your ML code. If I break it up, the software that we are talking about is nothing but your ML code. This ML code is developed using the data that we have got in the historical cases. All this has to rely on the performance is to be relied on the hardware, based on the hardware, right? So as I mentioned, this is going to be very important aspect, right? And it can be deployed on local machines or cloud machines, like Bernie has already mentioned. We will be talking more about this, right, probably in the next session. And yeah, that's a small gist of things that are going to come up your way, friends. Yeah, thank you, Nitin, for asking or bringing up that question.
Yeah, thank you, Sharad. Sorry, we are running out of time, so I had to, we could not listen to the full answer. But then, not to worry. What we are not completing in one session is being done in the next session. So the objective is that you will learn, and you will definitely learn everything there is to learn as far as any kind of interview. You should be able to crack it. The only thing that you must remember at your end is that you are attending all these sessions that we are so diligently, and we're taking the efforts to create the content and discuss amongst ourselves. So please do attend, do not miss out, attend it live, watch the recordings again. If you miss out certain things, give us recommendations with reference to what you would like to be added. And if you have friends, relatives, etc., who have actually attended interviews, and if there are any such questions or insights that you feel could be added, please do write to us. We'll definitely incorporate them. Everybody should stand to benefit with the knowledge that we are sharing. So on that note, please continue to subscribe, share, and watch the videos that we watch the YouTube channel that we are showing you here. And thank you so much, and see you all tomorrow. Have a great day ahead, and good night.
Thank you all so much. Bye.
Thank you, friends. Good night.